Hey guys, we're going to try to do notes a little bit differently today. So instead of you writing them down, just make sure that you're paying very closely to what I'm going to be doing on the screen. We're going to talk about line of best fit today and clustering and outliers in our scatter plots. So I'm going to go ahead and move the screen over to my computer stuff. So for here, we have the concept of what a clustering is. So when we talk about clustering in scatter plots, that means we're focusing on a set of points that are very close to each other. So remember, scatter plots, they don't form a straight line. They are kind of all over the place, usually following a correlation, like a positive or negative correlation. But sometimes we come across, what we call a clustering of the data. So for a clustering of the data, you'll see a whole lot of points that are going to kind of be piled together. So if you look at this example that I have here, we happen to have a cluster of points right here. Okay, if we talk about an outlier, so you guys do know that an outlier tends to be those values that stand out from the rest of the data set. Usually, if we're talking about just a single set of data, like when we were discussing measures of variability, like mean, median, mode, and range, and we were just given data points, like test scores, we knew that an outlier was a number that was either really, really, really small compared to the rest of the data or really, really large compared to the rest of the data. If you're looking at a scatter plot, visibly, you'll be able to see that it's completely on its own. So again, an outlier, it's going to stand out from the rest of the data set. So here would be our outlier in this example. And then this is a set of data points that I have here. So I was trying to find an example of something that we could use to display. So remember, scatter plot is used to show the relationship between two variables, an x variable, which in this case would be our temperature, and y variable, which would be our ice cream sales. So this local ice cream shop went ahead and was keeping track of what the temperature was that day at noon for the past 12 days. And looking to see if they could find any kind of trend when it came to the temperature outside versus the ice cream sales. Now, I know some of you are probably looking at this and going, who would want to eat ice cream when it's 14.2 degrees outside? Keep in mind that this is Celsius, so this is not in our Fahrenheit. So here, these are our values as a table, and this is what it actually would look like as a scatter plot, so plotting each of those points. So we notice that this happens to have a positive association or a positive trend. So remember, trend can be another word for association or correlation. That as the temperature seems to rise, so does the ice cream sales, like how much money you're going to make that day for selling ice cream. So warmer weather, more sales. That's what we're seeing right down here. Warmer weather leads to more sales. And it's not a perfect relationship, okay? It doesn't form an exact straight line. However, that relationship is pretty close that you might be able to see a correlation to it. And that's where we get those lines of best fit. So a line of best fit, or a trend line, is based off of representing the majority of the data. So you want your data set, you want it to go through a few points of your data set. You want to have an equal distribution of values above the line as you do going below the line. You want it to be as close as you possibly can to those data points. So the goal of today is to see if you guys can identify between a set of equations, which equation would represent the best line of or the line of best fit for these scatter plots. So let's go ahead and take a look at one example. So in this example, we're talking about resting heart rate, showing the years or the age of somebody in their years out of 24 students. And then the heart rate or beat per minute when they are resting. And so we've got different different data points, like this one looks almost like it's at a perfect point. This would be like a 15-year-old has a resting heart rate of 60. Over here we have like a 40-year-old with a resting heart rate of 50. What we're wanting to do is we want to try and create a line that would be a close representation to these points. So it's going to be very close through the points, have an equal distribution above and below. So the best thing you can do, especially if it's multiple choice, is see if you can eliminate anything. So the first thing you want to look at is what kind of association this is. So this is a negative association. Remember, it kind of goes in that negative direction, top left to bottom right. So this would be a negative association, which means that the line of best fit should have a negative slope. That's what we're wanting to look for. Now, I do apologize that I'm going to try to write with my finger on the mouse pad, so it's not going to come out very pretty. So it's going to have a negative slope. Or your m value. So keep in mind, remember when we talked about y equals mx plus b, that's our equation, our line for our equation, it should be a negative value. So if we looked at all of these, if there happened to be any one of the slope values not being negative, we know that we could go ahead and get rid of that. The only one that we could possibly get rid of at this point would be y equals 60. So y equals 60 is going to give us a horizontal line, because y equals 60 here, it also equals 60 here, it equals 60 here, it equals 60 here. So it's going to create this horizontal line, which obviously is not going to be a good representation for line of best fit. So let me go ahead and get rid of those points right there. So I can cross this off. So the next thing I want to do is check each of these lines. So the first one says that I have a y-intercept at a positive 80. So what I want to go ahead and do is plot a point at positive 80, and then I'm going to plot a couple of other points using that slope. Now the slope says it's a negative 2 over 5. That means I'm going to go down 2, and I'm going to go to the right 5. Down 2 and to the right 5. Now please be mindful, you need to make sure that your graph has a similar interval count for the x and the y in order for you to count by the grids. In this case, it does. Each of our grid lines represents a change of 5. So it's 5, 10, 15, 20, 25, 30. Same thing here. This would be 80, 75, 70, 65, 60, 55, and so on and so forth. So we could technically just count the boxes. So if I go down 2 and to the right 5, 1, 2, 3, 4, 5, I can put my next point right here. And then I can do it again, go down 2 and to the right 5, that's 2, 3, 4, 5, and draw my next point. Now when you guys are creating your lines, the thing that you want to make sure is that you've got a nice straight edge to connect them. So I happen to have a computer tool that is going to connect them perfectly. So now looking at this, the first thing that I should take note of is I don't have an equal distribution of points below and above the line. So this would not be a very good representation for my graph. So I'm going to go ahead and cross this one off and get rid of it. So I'm going to get rid of the line, get rid of those points because they're not a good representation. And I'm going to move on to the next one. So I'll go ahead and do this one in, we'll go ahead and do this one in blue. Okay, so for here, they have a starting point at 75. So 75 is located right here on the y-intercept, or the y-axis. And then again, it has a slope of negative 2 over 5, meaning I'm going to go down 2 points and to the right 5 points. Plot my next point right here. Then down 2 to the right 5. And plot it right here. And then I go ahead and connect them together. Okay, now this does happen to have a very fair distribution of points above and below the line. So I might go ahead and keep this one. It could be a possible contender, but I do want to check to make sure that there aren't any other better ones. So we'll go ahead and do the next one maybe in green. So for our last equation, we're also still starting at 75. So starting at the same point, but this time it says we're going down 3 to the right 5. So I plot it here, then down 3, and to the right 5. And automatically I can already see that this is not going to be a very good representation. Most of my points are going to wind up being above that green line. So I know that that's not a very good representation for my graph. So I can go ahead and get rid of those, and there's my final answer then. That graph or equation B is going to be the best representation. Let's take a look at a couple more examples, and then you're going to do some IXLs on your own. All right, so here, let me darken these lines real quickly for you guys because it is kind of hard to see them where the axes are. But we do have our y-axis. Oh, that's not very dark either. Sorry guys, bear with me. I'm trying to use this program for the first time. It is a very brand new program for me. All right, so here is our y-axis, and here is our x-axis. Okay, same thing for over here, our y-axis, and our x-axis. And I do believe that we have a couple of points actually graphed here as well that I want to make sure that we see. I think we had one right here. All right, so going right back to our points. For this first table, let's go ahead and take a look. The first thing I need to take a look at is the kind of trend. This is a positive trend. It is a positive trend, so that means that I need to have a positive slope. I want to have a very positive looking slope. So anything that has a negative slope, I can go ahead and get rid of that. So that means I can get rid of B and I can get rid of D because they're saying that the slope is going to be negative, and that would mean it would have to go in this direction. So right off the bat, I got rid of some stuff. I only have to check a couple of points. Now, both of them have 0 for their y-intercept, which works out because this happens to be a point that we do cross over. So I'm going to go ahead and check my first one. This one says that it's 4, which means I would be going up 4 and to the right 1. Well, automatically I can see that that's not going to be a very good fit, is it, guys? Because that is giving me a very large, very steep slope, and it's not a good representation. So we can go ahead and get rid of that as an option. So that means that the only one that we would have remaining would be 1 over 4, which means we would go up 1 and to the right 4. And that we would go down 1 and to the left 4. And right there, if I go ahead and connect those points together, that does give me a pretty fair representation. So there would be my line of best fit. We would go with answer choice C. Okay, if we take a look at the next problem, again, this is a negative slope. It has a negative correlation or negative trend. So that means I'm looking for a negative slope, and automatically I can get rid of answer choice. Ooh, that's not a very pretty E. Answer choice A I can get rid of because it has a positive slope, and answer choice C I can get rid of because it has a positive slope. So we're just going to focus on B and D. Now, B says that I'm going to start at a positive 2 for my y-intercept, so locate it right here, and that it's a negative 1 over 1, which means I can go up 1 to the left 1, up 1 to the left, up 1 to the left, or I could go down and to the right, down and to the right. So that happens to look like a pretty decent line already. If I were to connect those together, I'm going to change this to pink. If I connect these points all together, that looks like a pretty good trend line, a good representation of all of the points. D would not be a good representation because even though it does have the exact same slope, it starts all the way down here at the bottom, which means that I would have a line that looks more like this, which is not anywhere near any of my points. So that would not be a good representation. So we're going to stick with B. Okay, so what you guys are going to do now is go on to your IXL, and then you're going to complete a couple standards on line of best fit. Make sure you get a SMART score of a 70%.